All right, hello and welcome. Today we're going to be looking at rational word problems involving distance, rate, and time. So before we get started working the questions, let's look at the equation that they've given us, which tells us that distance is equal to rate times time. You may have also seen this written as rate equals distance over time, or time equals distance over rate. To make this a little bit easier, I'm going to kind of combine all three of these equations together. Notice that in both of the equations involving fractions, distance was always in our numerator, and our denominator was either rate or time, depending on how we had it set up. So using this little picture, we can decide how to set up our equation depending on the information that we've been given. So in this first example, Chuck and Dana have agreed to meet in Chicago for the weekend. Chuck travels 104 miles in the same time that Dana travels 96. So what we have been given are both distance. So what I'm going to do is write one equation for Chuck and one equation for Dana. So for Chuck, he is able to travel 104 miles. For Dana, only 96. We notice that Chuck's rate of travel is 4 miles per hour more than Dana's. And we're solving for Chuck's speed. So that means our x is going to represent a rate. And since Chuck travels 4 miles per hour faster, we'll go ahead and put a plus 4 on the bottom of this fraction. And finally, since the time that it takes them to travel is the same, we're going to make our fractions equal. So once we have our equation set up, we can use our proportion to solve. So I should see 104x equal to 96 x plus 4. So of course we're going to distribute on the right side. And we know that 96 times 4 is 384. Subtract our x's to combine like terms. And then divide. All right, so we've solved for x. We just need to look back at what the question was asking to know how to provide our answer. So it asked us for the speed that Chuck traveled. Well, Chuck had the fraction on the left. And since the denominator of the left-hand side said x plus 4, instead of just writing 48, I will say that Chuck traveled 48 plus 4, which is 52 miles per hour. Okay, so for the next one that we're going to look at, we're going to need to be familiar with the concept of traveling up and down a stream. So we're going to set it up the same way. We know that distance always goes on top, rate and time go on the bottom. So I see a stream with a speed of 6 miles per hour. So that 6 is going to go on the bottom of my fraction somewhere. I've got 94 miles downstream and 47 miles upstream. I know that when I'm traveling in a boat, if I'm going downstream with the water, I'm going faster than when I go upstream. So the downstream speed is however fast my boat goes plus the speed of the stream. I know when I'm going upstream, my speed is however fast my boat travels minus the speed of the stream. And then we've got our proportion that we can solve. So we should see 94 times x minus 6 and 47 times x plus 6. So you're going to distribute, combine your like terms. At the end of the day, you should get x equals 18. Since it asked me for the speed of my boat, I've answered the question that was asked. All right, let's look at one more of these. All right, so once again, we have a boat traveling in a stream. So Garth can row 5 miles per hour in still water. He can go 4 miles upstream. So the 4 is a distance. It's going to go on top. On the other side, he's going to go 16 miles downstream. The times are equal, so that's why I'm putting the equal sign. Remember, we said that upstream is slower. So the total speed is however fast he rows minus the speed of the water. When he's going downstream, he's going faster. So that's the speed that he rows plus the stream. So the equation that I'm going to solve is 4 times 5 plus x equals 16 times 5 minus x. So once again, you're going to distribute, combine like terms to solve for x. At the end of the day, we're going to get x equals 3. So since x represented the current, we have correctly answered the question. All right, that's all we've got for this video. So have a good day, and I will see you next time.